Selamat sore, Bapak. Yang belum ada ini. Oh, udah ada. Ibu sekalian. Pak Seswandi ini di mana, Pak Ses?
Di Palembang, Pak Wisnu.
Oh, di Palembang. Mana
Iya,
Palembang sekarang?
aman. Aman
Aman.
saja. Iya.
Keretanya itu masih
Backgroundnya apa?
jalan.
Apa, Pak?
Kereta dari bandara ke pusat kota itu masih jalan tuh.
Masih aman kok, nggak ada masalah sini.
Iya sih. Berapa kali? Dan bagusnya sekarang asap sudah jarang ya. Dulu kayak saya ke sana beberapa kali kena asap itu ya.
Iya, sudah nggak ini,
Kebakaran
Pak.
sudah. Hmm.
Aman, sudah
Yang,
nggak ada lagi asap.
yang penting empek-empeknya itu lebih original daripada kalau di Jakarta.
Oh, iya, pasti.
Anu sih. Apa cara makannya juga beda ya.
Iya, pakai cuka. Cuko
Iya,
kalau ini.
cukup.
Kalau di sini pepatahnya, kalau makan pempek tanpa cuko, itu apa lemaknya gitu.
Tapi ini kalau lucu sih kalau di Jakarta itu kadang-kadang saya terus ke daerah itu lo kok beda antara yang di Jakarta sama daerah gitu kan. Misalnya saya ke Surabaya
Iya,
makan apa itu.
iya. Di sini asli kalau bikin.
Ya.
Ya. Tapi kalau yang ada juga yang bikin pakai macam-macam sini banyak tergantung. Kalau harga murah itu ikan ikan sarden kalau di sini murah.
Ya, ya.
Kalau yang mahal tuh ikan ya ikan gabus, itu, ikan tenggiri
Itu Pak,
yang
kalau
enak.
Pak Seswandi asli Sumatera Selatan?
Oh enggak, kalau saya ini orang tua dulu dari merantau juga dari Jawa.
Oh, tapi lahir di
Iya.
Palembang.
Ya, lahir di
Hmm.
Palembang. Kami semua anak-anaknya lahir di Palembang. Jadi
Hmm.
apa namanya itu nggak bisa bahasa Jawa kalau saya cuma ngerti sedikit-sedikit.
Ya, mungkin bisa denger, bisa memahami, tapi kalau ngomong susah ya.
Ah iya susah.
Iya. Dari Jawanya di mana orang tua?
Di Jogja dulu orang tua.
Oh,
Bantul. Ya.
oh di Bantul. Berarti sering nengok ke Jogja, Pak Sis juga.
Nah, udah jarang. Kalau
Ya.
saya baru sekali ke
Oh,
sana. Baru sekali waktu SD itu tahun 70 berapa itu.
ya, ya,
Nah, tapi
ya. Kalau
keluarganya
saya,
di sana semua.
oh, kalau saya asli Jogja sih, jadi
Di
lahir
mana
di
Jogja,
sana.
Pak?
Saya di dekat, dekat Gudeg Wijilan, dekat
Oh,
alun-alun utara juga.
oh dekat alun-alun. Oh, iya.
Ya,
Iyalah.
ya, anu sih. Tapi saya itu selalu menganggap orang di Jawa itu nggak suka makan ikan. Kenapa? Padahal orang luar Jawa itu suka makan ikan. Itu pertanyaan besar saya.
Iya, iya. Kenapa? Katanya amis ya. Kalau di sini justru dipindang ikan itu. Mang.
Nggak tahu saya. Yang dimaksud ikan segar itu jarang didapat ya di sini.
Iya,
Kecuali ikan yang tawar ya.
iya. Kalau
Ya.
di sini ikan sungai tawar. Kalau di sini
Ya.
ikan tuh dipindang seperti ikan apa namanya itu?
Oh, ya.
Baung, ikan baung itu
Ya.
pindang. Tapi beda pindang Jawa dan pindang Palembang.
Oh, gimana
Iya,
Fit?
kalau kalau di Palembang kan pindangnya berair. Wah, ada kuahnya gitu.
Hmm.
Jadi ikan itu kayak seperti dikasih air tuh. Nah, pokoknya kalau di
Ya.
sini nyaman lah, enak.
Oh, ya sih.
Kalau di Jawa kan pindang beda. Pindang,
Ya.
bilangnya pindang, rupanya bukan berair.
Ya. Kata orang Sumatera, orang orang Jawa ini kayaknya ini kalau makan kok lauknya sedikit, kalau orang Sumatera lauknya banyak.
Iya, iya gitu. Nasinya sedikit. Tapi ya, rata-rata sini kalau lauk lebih dari satu orang.
Oh iya sih. Ini hanya pembicaraan di medsos sih. Orang orang Jawa itu mah lauknya sedikit.
Iya, saya juga gitu kalau training-training, kalau ketemu teman-teman dari Jawa tuh gitu. Ngambil,
Oh.
oh ini udah. Iya.
Iya.
Kalau di
Pak
sini
Utama
kan
gimana?
enak.
Iya. Oh iya sih. Makanya di Sumatera itu lebih mewah daripada di Jawa.
Oh, iya.
Selamat siang, selamat sore Pak Utama.
Selamat sore, Prof. Jarot. Apa kabar?
Oh, baik. Lama wajahnya nggak kelihatan.
Iya, keliling-keliling.
Oh,
Pak Siswandi, selamat sore. Pak
Selamat
Sis.
sore, Pak.
Apa kabar, Pak?
Baik.
Tadi ada Bu Jenny ya? Kok hilang terus?
Bu Geni, kebetulan ada tamu.
Oh ya, ya,
Jadi sementara off sambil ngikuti saja dari YouTube.
ya. Rupanya Pak Sis senang rendang juga ya, Pak Sis?
Pasti itu. Kalau
Rendang
rendang,
Padang. Ya.
iya, rendang Padang, Sumatera, Palembang juga banyak. Rendang enak juga.
Iya.
Tapi di Palembang ini, pokoknya kalau makanan tuh, pada kalau orang datangan pada, enak. Enak itu. Bilangnya enak semua. Nggak ada yang nggak enak. Nah,
Iya.
teman-teman kalau ada training di sini kan mampir, misalnya ketemu dari mana gitu. Suka itulah, wah enak di sini katanya. Hantamannya pempek. Padahal pempek itu bukan pempek aja di sini Pak. Di sini ada namanya tekwan, ada namanya model gitu.
Hmm,
Bukan
iya sih.
semata-mata pempek ya. Topnya memang pempek, tapi model dan tekwan di sini lebih enak juga. Terus ada mie celor khas Palembang di sini ada juga. Laksan makanannya kan udah
Oh,
burgo itu enak semua.
ini habis webinar terus kita jadi pengen makan ini.
Iya iya. Anu Pak Pak Wisnu ngomong-ngomong nih,
Ya,
aku tanya dikit ya. Nuklir
boleh.
nih dari saya tahu tahu itu di tahun 80-an saya SMA itu sampai sekarang kenapa nggak jadi. Terus katanya mau di Bangka itu kapan pelaksanaannya?
Ya, ini kan sebenarnya keputusan politik ya. Kadang-kadang politisi itu kan melihat apakah ketika memutuskan go nuklir dia akan populer atau tidak. Itu
Iya,
satu. Kedua, apakah juga masyarakat Indonesia itu sudah siap, budaya keselamatannya sudah tinggi atau tidak? Kalau saya sering berbicara dengan entah itu menteri, entah itu dengan pimpinan negara itu.
iya.
Itu
Saya
kemudian
ini apa? Ya lanjut Pak.
ya, tetapi akhir-akhir ini pemerintah itu suara terhadap nuklir itu kencang. Karena apa?
Hmm,
Menuju net zero emission itu tidak ada cara apa ya lain untuk menggantikan PLTU batu bara kecuali dengan
Iya,
di
iya.
antara dengan PLTN.
Ya soalnya di kami kan pembangkit listrik itu pakai batu bara karena di sini kan penghasil batu bara.
Ya,
Terus ke Bangkas itu kalau dari Palembang cuma nyebrang satu apa menyeberang 4 jam 6 jam lah udah
hmm,
sampai ke sana. Nah, saya nih lihat-lihat katanya mau di sana nuklirnya. Sampai
ya,
sekarang nggak nggak jadi-jadi. Saya itu tahu dari sejak saya SMA tuh tahun
ya.
80-an itu kan. Kapan ini nuklir Indonesia kok dari dulu-dulu sampai sekarang saya sudah mulai berumur gini
Ya,
belum ada tanda-tanda masih apa
ya,
namanya penelitian penelitian padahal kita kan banyak yang sekolah keluar tentang nuklir.
ya, ya. Moga-moga dalam waktu dekat lah. Kalau pemerintah itu mencanangkan di 2030-an. 2030-an kan berarti tidak lama lagi tuh. Tapi
Iya,
perlu persiapan sih. Di antara yang pilihan untuk lokasi ya Bangka itu.
iya mangga mangga
Ya,
Belitung karena sana daerahnya pasir Pak dekat laut jadi kan aman sebenarnya.
moga-moga juga. Dan
Iya,
tidak ring of fire itu. Ya,
iya betul. Ya
saya
kemudian apa
agak
namanya
ya, saya harus memulai sekarang sudah pukul 16,
iya
Bapak Ibu
silakan.
semuanya. Eh, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera untuk kita semuanya. Sore ini kita akan mengadakan webinar ke-21 tahun 2024. Ya, kali ini kita akan mengundang kembali Pak Subing dari China, dari CNNC, yang 3 minggu lalu hadir menyampaikan presentasinya terkait nuklir di Tiongkok. Kali ini khusus membahas small modular reaktor mereka yang saat ini masih dibangun dan rencananya 1 sampai 2 tahun ke depan akan beroperasi. Itu menjadi salah satu opsi bagi Indonesia. Karena Indonesia, seperti tadi di pembicaraan sebelum masuk ke webinar, kok sudah lama kita siapkan, tapi tidak juga dibangun PLTN. Nah, pemerintah dalam hal ini beberapa kali selalu menyatakan nuklir adalah salah satu jalan keluar kalau kita ingin eh, mentargetkan net zero emission 2060. Dan Dewan Energi Nasional menyatakan 2032, atau kalau ESDM menyatakan 2033, kita akan mengoperasikan PLTN. Dan prioritasnya yang skala kecil atau menengah, dalam hal ini SMR atau Small Modular Reactor. Nah, ketika kita mencari Small Modular Reactor, pilihannya itu sebenarnya tidak banyak. Tidak banyak karena apa? Small modular reactor relatif teknologi yang didesain beberapa dekade terakhir dibanding yang PLTN besar. PLTN besar itu 1000 megawatt, 1400 megawatt. Sementara small modular reactor bisa jadi 100, 200, 300 megawatt. Itu small modular reactor. Dan ditekankan karena modular, bersifat modular itu mestinya pembangunannya juga cepat. Nah, dengan pilihan sedikit, itu Tiongkok atau China atau RRT itu adalah negara yang boleh dikatakan leading, mungkin yang terdepan dalam hal pembangunan small modular reactor. Ide desain itu banyak, mungkin ratusan ide atau desain. Tetapi siapa yang sudah membangun, siapa yang mengoperasikan itu sangat sedikit. Mungkin ya kalau di antara sedikit itu yang sudah mengoperasikan Rusia dengan PLTN terapungnya. Nah, kali ini kita akan mendapatkan gambaran dari Pak Subing. Pak Subing itu sering kita panggil sebagai Pak Musa. Eh, Dia adalah International Development Center ASEAN Regional Development Headquarter. Jadi Chief Representative of Indonesia. Tapi sebelum saya perkenalkan, saya tidak perlu memperkenalkan sebenarnya karena beberapa minggu lalu sudah kita hadirkan di webinar ini. Eh, Maka mungkin saya akan bercerita sedikit saja dulu sebelum memperkenalkan. Jadi ACP100 di antara kata 100 itu sebenarnya dayanya sekitar 100. Ya, sekarang sedang dibangun, ya. Dan itu bisa menjadi opsi kita. Memang obstacle atau tantangan yang dihadapi terhadap pemanfaatan nuklir dari Tiongkok di Indonesia itu banyak. Namun tentu saja tantangan itu bisa kita lihat secara objektif. Kadang-kadang kita juga cukup subjektif terhadap negara tertentu. Oh, ini made in mana. Nah, nanti kita akan mengadakan webinar menggunakan bahasa Inggris. Menggunakan bahasa Inggris yang kita harapkan apa namanya, dengan bahasa yang Inggris yang sederhana tentu saja. Kalau ada pertanyaan pakai bahasa Indonesia pun silakan, baik melalui langsung, kita harapkan langsung, maupun melalui chat yang kita sediakan. Nah, sebelum kita masuk ke acara utama, seperti biasa, saya akan menyampaikan video klip. Tapi sebelum ini, saya menyampaikan izin dari Pak Ketua Umum HIMNI, Profesor Susilo Widodo tidak bisa hadir dalam acara ini karena beliau mengalami musibah beberapa hari yang lalu ketika berada di Jogja. Tapi sekarang masa pemulihan, jadi ada waktu menyeberang di Jogja ada kendaraan yang menabrak beliau dan masuk rumah sakit. Tapi sekarang kondisinya membaik. Moga-moga kita doakan beliau pulih kembali seperti sedia kala dan beraktivitas dan hadir di acara kamisan yang kita lakukan. Saya akan menyampaikan video klip singkat terkait keanggotaan HIMNI. Oke, saya akan memulai dalam bahasa Inggris. Good afternoon, Pak Subing, Pak Musa. Oh, you are there.
Yeah,
Okay.
good afternoon,
Yeah,
Dr.
how are
Tojat. How are you? Good.
Yeah. Well, I heard you have a virtual meeting yesterday with our organizations.
Yeah. Yesterday we had a meeting with your all organization and different centers. Yes.
Okay. We are going to start these webinars, but I would like to introduce, although I have already introduced you several weeks ago. Let
Thank
me
you.
introduce you first. Pak Subing or Mr. Subing or Pak Musa, you can call him Pak Musa. You can greet him with Assalamualaikum, and he's very fluent on this kind of greeting. He is the International Development Center, ASEAN Regional Development Headquarter, Chief Representative of Indonesia, and he is have a long experience in Pakistan project, around 10 years, Pak Musa, is it?
Yeah, 10 years.
Yeah. So when I said to him last week, please, I would like to invite the speaker on the status of ACP100. He said, yes, I can give you the explanation. It means he's an expert on this kind of small modular reactor or nuclear energy. So I would like to give you the time for your presentation. Please, Pak Subi.
Okay, so I should share our PPT by myself, right?
Sure.
Yeah, okay. So first, I would like to share with you regarding the PPT. So China National Nuclear Corporation overseas, which we are always say that integrated solution for nuclear power development. So basically, as Dr. Tojat already introduced me, I will not further to introduce myself. Now is that let's know about CNNC and CNOS. CNNC, China National Nuclear Corporation, it's a state-owned enterprise with nearly 70 years experience in the nuclear field. It is the sole part of a whole of complete nuclear industry in China. So currently, as by our organization, so we have 185,000 plus employees, and we are also stands Fortuna owning a nuclear group stays in the Fortuna 500 381. And we under the CNNC we have more than 1,400 plus subsidiaries, and annual revenue of CNNC is 39.05 billion. It is the latest story. And for the CNNC, as I told that CNNC has a complete nuclear industry chain over nearly 7 decades since it was founded. CNNC has acquired a full mastering of internuclear industry chain from front end to back end, which covers natural uranium and nuclear fuel, the nuclear energy, and radioactive waste disposal, and the nuclear facility and nuclear technology application. And for the nuclear power development, and CNNC has constructed many types of reactors from generation 2 to generation 4, which including CMP300, CMP600, CMP1000, HPR1000, VVER, ACP100, CANDU 6, ACP100, and HTGR. So for here, I would say that for CMP300, CMP600, CMP1000, HPR1000, and ACP100, HTGR, it is from CNNC. It is CNNC has totally intellectual and design of these reactors. For VVER is from Russian, and the ACP100 is from American. CANDU 6 is from Canadian. So up to now, by the end of May 2024, as controlling of shareholder, CNNC has 26 units in operation, out of 57 units totally in China. And under CNNC, we also have 18 units is under construction and approved, which out of 36 units totally in China. So for the CNNC, as a state-owned company, and also we are on behalf of China government, for the nuclear development, we have a 3-step, and we adopt a 3-step strategy for the nuclear energy development, which is thermal reactors, too fast to fusion reactor. You can see that we have a 3-step. First is the thermal reactors, which is using uranium-253 and mature technology and bondly constructed. And the second one is a fast reactor, fast neutron reactors, which is using uranium-238, which has high efficiency utilization rate of uranium resources, and the spend fuel greatly reduced. And the third step is fusion reactors. Fusion reactors, it is the highest thermal efficiency and no risk accident, such as supercritical L fuel mentally. We used to call fusion reactor is a small sun. And the CNNC, it is founded on April 25th of 1983. And the name is China National Nuclear Corporation Overseas, wholly owned by subsidiary of CNNC. It is a leader and a designated platform specialized in overseas marketing development of a complete nuclear industry chain. So we have an integrated solution. Under CNNC, we have a construction company, we have design institution, we have a fuel supply, we have a operator and services. So we can provide complete services for our international partner. So over the past 40 years, for CNNC has successfully exported 7 research units and 7 nuclear power plants in international market. Especially, we have exported 7 units in Pakistan, and we have built 2 nuclear bases in Pakistan. And totally installed capacity of nuclear in Pakistan is 3,055 megawatt, and the generation capacity is around 70 to 23% of total energy. And also, by the way, we also export 1 unit in Argentina. We have signed a contract in 2022. And also we have a research reactor in Algeria, Nigeria, Iran, and Pakistan, other countries. So So what we have that come to know that we can provide a big unit like HPR 1000. The designed capacity is around it's around 1,200 megawatt, and also we have a success demonstration plant in China and in overseas. And also we can provide small reactors like HTGR. So we have a demonstration plant also in China, in Shandong province. And also we have ACP100. And ACP100 is basically it is a new generation of a small and elegant MPP developed.
Excuse me, Pak Musa. Could you please to show us the full screen?
Yes, sorry. Okay, just give me 1 second. It's okay now?
Yes. Yeah. Thank you.
Okay. So for ACP100, it is a new generation of a small and elegant MPP developed on the foundation of inherent mutual technology aimed at boundary user featuring with easily connected to small and medium-sized power grid and the urban region heating supply, industry process steam supply, and the seawater desalination, and even the hydrogen production. For the ACP100, so I have to emphasize that it is already it is the first SMR in the world and also get approved by the IAEA, and it is also constructed in China in Hainan province, and this SMR is going to be got commercial operation by end of 2025. Currently, it is under commissioning stage. For the SMR, for the technology of features, so we have a full multi technical features. First one is advanced integrated reactor. Second is a passive design of safety system, and which also have a multiply application and modular reactors. So here I would say that for the SMR, so it is SMR ACP100. It's adopt integrated reactor design technology along with the passive system safety system, and incorporating comprehensive measures for the preventing and mitigating services accidents. So for the SMR, you can see here it is in integrated design, canard bomb connected to the IPV, and once through steam generator, integrated reactor hiding design. And you can see all of the design features over here. For the demonstration plant of ACP100 in China, I would introduce here that ACP100 installed capacity is 125 megawatt. Design life is 60 years. Fuel refilling cycle is 24 months. That once you fill in the fuel, you can continue running for 24 months. And the availability factor is more than 90%. Safety shutdown earthquake is 0.3 G. And the FCD time, FCD is a start of construction time. We can say is the first concrete date of ACP100 in China in Hainan. It is start from July 13th, July 2021, and planned COD. COD is a commercial operation date. Our planned COD time is December 2025. Construction period is around 53.5 months. And you can see the milestone of ACP100 in China. It is start from 2021 and end will be 2025. And for the function applications, ACP100 we can it's aimed at boundary user featuring with easily connected to small and medium-sized power grid, heating supply, industry process steam supply, seawater desalination, and floating nuclear power. So you can see the right side, the ACP100, which can connect for the small and medium grid for generation of electricity, and also provide heating plus electricity, steam plus electricity, and water desalination plus electricity. For the overseas, as by our experience in China, and also our nuclear power construction experience in foreign country, we have conclude that refer to the information for overseas ACP100. For single unit, the construction period is 48 months, and for 2 unit, construction period is 60 months. The capital cost of a single unit is start from 8,000 to 10,000 US dollar by kilowatt by hour, and for 2 units, the cost is around 6,000 to 8,000. And the plant land size is for single unit is 25 acres, and for double unit is 35 acres. So for the construction, so we, as I explained, we're here by the end of 2024, since it has successfully constructed 63 MPPs, which included domestic and overseas, which across multiple reactors, start from 125 to 1,750, and has capable to build up to 40 MPPs simultaneously. So now I would like to introduce another PPT, which is especially focused in the ACP100, and you can see here, and for the SMR ACP100, as we all know that ACP small modular reactor, it is emerged in the future for the nuclear industry development. So we all, as by the word in promotion, we all have a common sense that as by the global growth in the electricity demand and the traditional energy challenge, for the carbon peak, carbon neutrality, and the demand for the clean, low carbon energy, traditional energy challenge with a new energy solution. So IAEA, International Atomic Energy Agency, has proposed SMR as a solution, as the only solution for the global energy change, which can salute for address global energy challenge and small modular design. The China is a first, it's a first country which constructed small SMR in the world, with a symbol for China commitment to innovation, marks and a crucial breakthrough for China in the field of nuclear energy, setting a historical record for the global nuclear energy development. So for the SMR, we can say that there is a 3 major advantage. So first one is a proved technology, second one is advanced safety, and the third one is a deployable. For the more mature technology based on the 40 years experience in the nuclear power experience of CNNC, our technology has got approved in IAEA and international agency, and also China government and the regulator body. And for the safety, for the SMR, which is fully passive safety system, and with a highly efficiency, and which can provide the most stable and safety energy and multiply purpose to the country and to the city as well. So we can see that currently, as I already explained, the general information for SMR, you may have a better understanding, like design capacity, design life, plant availability, and also for the core damage frequency and the large earlier relief frequency. So basically, you can see this. It is a layout of SMR in relevant parameters, and we can see that safety system and approved fuel, I&C instrument, approved supply chain, and the construction ability, length, steel composite structure, modular, and the OMM procedure and the practice, and the refueling cycle 24 months. This is all the basic specific of SMR. As all, we can see the design, which adopt integrated design. For the ACP100, you can see that which is integrated layout instead of loop type, and also main pump directly connected to the reactor's pressure vessel. The nuclear steam supply chain integrated to the reactor modular, and the integrate head package design, and also the CRDM and the pressure vessel reactor internals, and also canard motor pump are all in mature technology. This is a general as we can see here. This is a plant layout, and which contains two major parts. One is the N island, and another one is a C island. Ni is a nuclear island. Ci is a conventional island. So for the N island, Ni building, which is many includes reactor cooling system and the ESF, important nuclear auxiliary system, and also there is a fuel building which installed for the spent fuel pole and the new fuel area, and the third one is a nuclear auxiliary building, which included the nuclear auxiliary system, electrical and instrument control equipment, and also for electric building. Electric building, we can all say that it is included equipment for the instrument control electric system. For the purpose of SMR, we are content multiply purpose, as we all can say that multifunction MPP for the diverse utilization, supply of electric power to media small grid, island, and also the remote mountainous area, which can supply the heating power to the city, supply of steam and electricity to the industry enterprises, and also industry parks, and coupling with petrochemical industry enterprises. And also we can provide a provision of seawater desalination to the coastal city, lack of fresh water in island city. And also we can use in the provision of power to icebreaker and float nuclear plant. And for this is a flexible application for the SMR. Next, I would like to this is the most advanced safety. I would introduce. You can see that full passive safety facilities, independent external power supply, and non-intervention period more than 3 days, and the containment installed in the sheltered building avoid overpressure filter and radioactive leakage. And the underground layout of reactor building enhanced protection against external hazards. You can see here, as we are showing, that reality and deployable for the SMR. We are providing the fully live services, nuclear fuel, modular construction, and reliability O&M. So for the demonstration of ACP100 in China, as we can show here, which starts first SMR in the world to pass IAEA safety review. It's start from 2016, and then come to the 2021 we have start FCD, then come to the 2023 the modular ACP modular reactor core hoist complete, and for the in 2023 the steel has been complete. Now we are under the commissioning stage, and probably we will reach it will be got commercial operation in 2025 by end of 2025. And now I would like here I just quickly show the milestone of ACP100 construction in China. And here I would like to introduce. You can see that in the conventional island, for the conventional island main structure, the size of the main structure is from 15 to 19 meter structure. Under construction, the steam under conventional island, which contains steam tuber function, the structure below, and the platform under construction. Actually, this is previously construction pictures. We want to show you what is a general layout of SMR in China. And for the advanced benefit of ACP100, which can supply electricity over 520,000 family by year, and reduce 350,000 tons of standard coal by year, and reduce 880,000 tons carbon dioxide emission, and which equivalent to 7,500,000 tree planting, and which also can create 2,000 plus direct jobs, and also indirect jobs around 8,000 plus. And in the economic considering, ACP100 prologue plant design life is 60 years, and the high plant availability is more than 90%, and I explained before. For the future goals in China, for ACP100, for significant cost reductions to 4 billion, and the construction period shortened to 40 months. So this is actually advanced, which I already explained to you before. So I will no more given the explanation. By the way, I will emphasize that here the CNNC has a complete industry chain. We can provide a comprehensive all integrated regional workshop for on technology development and the application of small modular reactors in the global world. So this is a summary of SMR. So we are confident that CNNC has accumulated a lot of experience in the construction of a smaller modular reactor, including site selection, safety review, equipment manufacturing, civil engineering, and operation. CNNC is willing to share the experience with member states in near future. Okay, thank you very much. This is all my introduction regarding the SMR.
Okay, thank you very much, Pak Musa. Ladies and gentlemen, if you have any question, please raise your hand, or you can write down your question in the chat room. I have two questions, Pak Musa.
Yeah, please.
Well, I think your presentation is always impressive presentation because you show us the progress of the China that at the same time you build many NPP.
Yeah.
And my question is there any or are there any anti-nuclear movement in your country, for example? This is very important for us because we failed to deploy or to implement the nuclear energy program in Indonesia. One of the reasons because the anti-nuclear movement in the past, some demonstration of anti-nuclear. And do you have any like a public acceptance program for this kind nuclear energy program to, for example, to explain and to make understand everyone, the common public, this is nuclear. There is a risk, but many benefits. This is my first question. If is there any public acceptance program or dissemination or promotion? The second one, you show us also your history that you collaborate with many countries. Can do with Canada, VVR with Rosatom Russia, and ACP100 with the Westinghouse United States. How do you make like to make you how do you make a transfer of technology that then you can make by yourself your nuclear power reactors? Is there any program by the government, by central government, for example, to every vendors, the foreign vendors, to have a significant transfer of technology or something like that? Please, if you have any explanation on these two questions. Thank you.
Yes, so I will first answer you in the first question. So first, for the first question, for the nuclear program development in China. So usually we have a follow step. First step that the government has to make a plan and for the development of nuclear power. So every year there is a central government meeting. So all state members, which are around thousands of people, they will review the country energies, nuclear energy development. First, they will review and make a plan, and they will pass the development of nuclear energy. And the second, then we'll go to the nuclear regulator body and the nuclear safety body to get approved for the for the technology of a nuclear power plant, whether the technology is a standard and it is a state in the advanced safety. Then after they prove, then there is a public hearings and will introduce to the public that how is a nuclear and what is the rule of a nuclear, what is the working simple working system of nuclear, what is the advantage of nuclear. Then we'll hold the public hearings for the people to know the nuclear power. Then after that, then we'll start propose a project and getting the government approval. So this is all a program which we are develop nuclear power. And by the way, we also have a nuclear laws, and we also have a nuclear public promotions, and we also have the program which you can say it is a documentation program to explain and to share with the public what is a nuclear, what is a program of a country nuclear development, what is a nuclear advantage, or what is a benefit. We all are given to the knowledge to the people. In China, people much aware about nuclear, and they are in the citizen of Chinese government or Chinese officials, Chinese citizens. They are fully support, and they are aware of nuclear technology. And this is your first question. For the second question, we for the CNC, we have a lot of experience, no matter in domestic and international. For nuclear program development, we are previously look back to the 10 years before. We are for the development of a nuclear program, we are adopt two ways. First way is we design, we develop, we research and develop by ourselves. And the second, we import foreign technology. We import and we get rights transfer, intellectual transfer, technology transfer. Then we start construction imported nuclear power plant in China as well. Why we are import? Because we want to learn, and we learn and we will compare what is the advantage between our domestic nuclear power plant and the international nuclear power plant. So now we have a better conclusion as by our latest third generation nuclear power plant in China and in domestic. So HPR1000 for the HPR1000 and the ACP100 and the HDJR. Now we are leading the nuclear development in the world.
Okay, thank you.
Yeah.
My second question is, well, correlated with my first questions. Have you any public survey, for example, during our era in Batam organization, we conducted many years the public survey, national public survey, and the last one in 2016. The result shows that more than 70% of the public Indonesia support the nuclear energy. Although there was a NIMBY, not in my backyard phenomena, especially in Bangka Island at that time. Do you conduct also the public survey, so it makes you confidence, for example, to build in one location?
Yeah, we are used to conduct a public survey as well. And this is a basic. This is a mandatory. Yeah.
Okay. Yeah. Okay. Thank you. How about the NIMBY phenomena? Not in my backyard. Is there any in your country also?
What? Sorry.
Not in my backyard. It means some people, for example, in one area said we support to build the nuclear power plant, but not in my area. Okay.
Not yet. Actually, you see, in China, in the citizen, no matter from citizen or management or government officials, they are all fully aware about nuclear technology. and also basic on the Fukushima accident. So our technology is advanced with advanced safety. So our nuclear site selection and evaluation, it is all got approved, agreed by the local citizens, local government, and the central government. And the site selection site is fully evaluated by the citizen and also relevant organizations. So we are controlling in the safe condition, but this is for the coastal area. For if let's say that previously China plans to construct an inland nuclear power plant, like we constructed a nuclear power plant in the inland, but this is still not got approved because inland they have a shortage of the water, and also in the inland there are huge immigration of humans and the citizens. So we are prefer to select in the coastal areas. But in inland, people mind there. I do believe there is some people. If we are going to construct the nuclear power plant in the inland, of course they will be against from the populations. Because in the inland it is a lack of water, and also the humidity of population is huge. Yes.
Okay, thank you. And we are going to discuss about ACP100. You said that for the construction period, for the first, it takes around 53 months. But my questions is not the construction period. From the announcement that the government would like to build the ACP100 until, well, next year in operation, totally how many years? Because construction time, sometimes we talk about only construction time, but we need to know about the sometime the licensing from the regulatory body, that it takes time, for example. So my question is, from the announcement from the government or the contract until maybe next year or 2066, how many years it takes?
This I have to answer you in two answers. First answer, we start from earlier, like a government announcement. From announcement, then after government announcement, we'll have a site evaluation, site selection, site evaluation, and also approval of project in the country. Till nuclear power plant constructed, it will be take 6 years. 6 years. And for the construction of a plant, it is only need 4 years, 4.5 years. Yeah.
So this is my first. I have to learn a lot from your side, because if the government decide to build like ACP100, for example, this year, 2024, and we learn from your side about the construction and others, licensing and many things. It means it takes 9 years from 2024, or maybe less.
No, less. You see, like there is a major step. Okay, I explain to you for the development of nuclear power. First step, government announcement, and the second, we'll have all evaluations like site selection, site evaluation, environmental assessment, and water assessment, and also contract negotiations. This major step might be needed, and also for the government approval. This 6th step might need 2 years.
2 years.
Yeah, And for the construction of nuclear power plant, start from COD to FCD to COD, it might be need around 4.5 years. Totally, you can say 6 to 7 years.
Yeah, okay.
For development of nuclear power plant.
So it means you are optimistic if, for example, this is an example, the government decide to build, the Indonesian government decide to build, and they announce this year, it means you can reach the target in 2032 or 2033, isn't it?
Yeah.
Okay. Yeah. Thank you.
Because there are major steps. Yeah, please.
Yeah. Although I think there are many difference on the regulation between the regulation process between China and Indonesia, I believe. So maybe you are experienced in your country on the many licensing, many requirements, but here in Indonesia, maybe it takes more time, maybe.
Yeah, to be simply, you can see for the construction of nuclear power plant, there is a major step. First step is a government announcement, and the second is relevant assessment, and the third one is a design review by the regulator body. Then will come to the government for the approval. And this is this 4 major steps should be conducted before.
Okay. So we learn from the current projects. Maybe it takes around 6 years, isn't it? In your current projects. Okay. And comparing with when you build a large NPP, at the moment, how many years it takes when you build, for example, in Pakistan with the more than 1,000 megawatt electric? Is there any significant difference on the construction period, including the licensing and others?
You mean for the overseas or China?
Okay. Let's first in China.
Construction period.
Yeah.
In China.
We compare the large and the small modular reactor, ACP100.
ACP100. First, for the large units in China, we need for the like HPR 1000 construction period is around 5 years.
Okay, 5 years. Okay. Not so different.
In China. Yeah, in China. And for the international construction of large scales MPP is around 6 years.
Okay.
6 to 6.5 years. Yeah.
Okay. There is one question from the audience. This is a general question. I have to read this one. Tadi ada yang nanya thorium ya? Oh, malah hilang. Well, I would like to ask Pak Subhan to open your video and your mic. Pak Subhan, you can ask directly. Ya, mau ini enggak videonya dimunculin?
Takut komunikasi internetnya terganggu, Pak Jarod.
Silakan. Ya, please, Pak Subhan.
Okay, thank you, Mr. Jarod, for your time and great presentation for Mr. Subin from CNNC. My name is Muhammad Subhan from Brain. I'm so interesting from your presentation. I have 2 questions for you. So you said before you have like STRPM in China and already connected to the grid. So my first question about your presentation, if we compare with STRPM with the ACP100 in the term of the technology and safety, Which one is better according to your knowledge and experience, and why? Please, could you explain? And second question, about cost. We know that the STRPM is the very high cost because it's the generation 4. So my second question is, for a development cost between STRPM and also for ACP100, which one has cheaper development and construction cost? Could you explain? Thank you very much.
Please, Pak Musa, you may answer the product of your companies, both of them.
Okay, can you hear me now?
Yes.
Okay, first let me answer the price difference. Okay. For first, let me tell you the for the SCP-100, as I explained, SCP-100, the capital unit of capital cost for 1 unit is around 8,000 to 10,000 US$ by kilowatt hour. If you construct 2 units together, then the cost will be reduced. It will be cost around 6,000 to 8,000 US$. This is the SCP-100. Okay, and for HDGR, just 1 second, I show you the HDGR. Sorry, just wait. I show you the cost of HDGR. I will share my screen with you to show you what we can offer you. Okay, can you see this? Can you see my screen?
Yeah, yes.
It's clear?
Yeah.
Okay, you can see this is a HDGR. So for the cost of HDGR, you can see here that for single unit it's around 6,000 to 7,000, and for the 2 unit it's around 5,000 to 6,000, which you can say that HDGR is cheaper than ACP100. But you know which one is better, and also which one is much capable for China or for international country. As you know that now in China we have a demonstration plant for HDGR. We have a demonstration plant for ACP100. Basically, that for 2 different units, we are prefer both. Why? Because both for the HDGR, it's good in it's good for the petrochemical coupling plant supply to industry. The advantage of HDGR is good to supply steam to the industry. And for the ACP100, it's good in the supply electricity and seawater desalination and the steam supply chain. For the comparison of multi-plug function, we can say that both are best one, and both are using the different requirement. Like in China, currently we are developed HDGR for coupling cooperation with the chemical industry, and for ACP100 we are aimed to using multifunction for the seawater desalination and the hydrogen, and also for the steam supply in the domestic. From data, you can say that HDGR currently is cheaper than ACP100, but it is a first demonstration plant. as we all say that in the future, we'll bring, like when we are going to second plant or any other plant in the international market, we'll bring the capital cost lower than the HTGI, because ACP100 is a modular reactor, and also it's easy and convenience for the small island, small cities, small grade and media grade. As by the function of small modular reactor, ACP100 is much convenience for the international market.
Okay, Pak Subhan, do you have any questions? Oh, sorry. Please unmute yourself. Sorry.
Okay. Thank you for your presentation, for your explanation. So, I have some curious for your answer about the technology, the specific technology, because the ACP100 is like PWR, right?
Yeah.
PWR, right? Yeah. We know that there is some big problem with PWR because there is like the water in the inside in the core of reactor, but in the STRPM there is no water because the STRPM there is a using like a helium, right? So it's mean more safety and more enhanced to the like passive cooling system. So could you explain specific about the technology for your like SCP-100? Like the more efficiency, the more significant of the technology, the more significant for safety, something like that.
This I think I already explained in the before. Sorry, I can show you the document for ACP100.
Okay. You comment.
Okay.
Okay.
Masih ada pertanyaan, Pak Subhan?
Okay, thank you, Mr.
Thank you.
Thank you.
Just let me show you the technology of ACP100. I will share the screen with you. Maybe you're, or just let me share my screen. Can you see my screen now?
Not yet.
Not yet.
Not yet.
Sorry for inconvenience. I have to find it.
But the interesting one is that HTRPM cheaper than SCP-100. I thought that SCP-100.
Currently, it is a cheaper, but
Okay.
in the future, ACP100. Sorry, let me. I could not find our meeting. Okay.
Yes. Yeah.
Can you see?
Yeah.
You can see.
Okay. Yes.
Right now, you can see this is the design of SCP100. So you can see here that layout and also the design features. It is an integrated layout instead of one loop. It's more safety, and the main pump is directly connected to the reactor pressure vessel. It's directly connected, and also the nuclear steam system is integrated to the reactor modular. You can say it's everything. It is in the modular reactors, and it is in one container. So you cannot, you don't need to have another auxiliary building to fix the smaller reactors. And I'll show you next features also. And for yes, you are right. It is using the water cooling, and everybody worry about maybe the leakage and the high radiation has water. But there is a three channel for water cooling. First channel, it will be fully processed by the chemical input. and it will be reduced and resolve all irradiations. And then they will come to the second channel, and there's another process system, and then come to the third channel. It will be completely isolated, all safety considerations. And for the HDGR, you are right that it is using the gas cooling. But the disadvantage of HDGR, it is a fuel, because the fuel cost is high, and also the fuel cannot reutilized in the future again. This is the disadvantage of HDGR.
Okay, I think each type of technology they have their own advantage, I think. But it is good to know both of the technology, high temperature gas-cooled reactor and pressurized water reactor, is well developed by the Chinese. I mean, you want to maybe in the future to produce the hydrogen, maybe you want to use the HDGR, and still you can make electricity while using for the hydrogen production, maybe. But there is one question from the audience in YouTube, from Dr. Suparman, I think. He is the expert on economy, nuclear energy economy. It means you show us the unit capital cost of the ACP100 around 6,000 to 8,000 US dollar per kilowatt hours, isn't it? For unit capital cost of the ACP100. And his questions also, how about the electricity cost or electricity price if you sell it to outside?
Okay, for the cost of ACP100, if you are that depends on the 1 unit or 2 unit. If you construct 1 unit, it will be the cost will be high compared with the 2 unit. For the single unit, now it is around 8,000 to 8,000 US dollar to 10,000 for single unit, and for 2 unit cost is around 6,000 to 8,000.
Okay.
And the tariff.
Yes, and tariff.
The tariff is around. It is a tariff is around 8 cents.
8 cents per kilowatt.
Yeah, 8 cents to 8 to 9 cents. Yeah.
Oh, okay. So I think Parman or Dr. Parman hear this or watch this in YouTube. There is another question.
But you see, it is not the cost, the capital cost, and also the capital cost. The tariff depends on the capital cost. The capital cost depends on the country industry chain.
Okay.
And because if you have a good industry chain and also resources for the supporting, so then the cost will be reduced.
Okay, because this
we
is very
can adopt all equipment and also resources from local. It depends on the local industry development.
Yeah, okay. Because the government or decision maker, especially Indonesia, they first would like to know about how about the capital cost, and then second, if we build that one, how about the electricity cost or electricity tariff that we can make. This is very important for us also, but you have already show us that the value or the numbers of the capital cost and the tariff.
Yeah, Dr. Dojat, you see, I have to emphasize that for nuclear power, in the starting, you can say that there are 2 major periods. First is payment, loan payment areas, and also operation period. you see during the first 20 years, you are making repayment to the bank, and you are making the principal and basic to the bank. So during the first 20 years, the tariff is around 8 to 9 cents. But after you finish loan repayment, then the tariff will be reduced to the 4 cents, 4 to 5 cents. After loan repayment period, the tariff will slightly reduce. It will become cheapest energy in the energy mixture.
Okay, yeah, I understand. I think it's very logical. There is another one question from Pak Budiono. Pak Budiono want to ask directly through the video? Oh, he's already left the meeting. He asked, well, I will read it. Please correct me if I'm wrong. If it take a conclusion from announcement period of nuclear power plant until commissioning and obtaining operation permit, it takes about 9 to 10 years. I think you have already explained previously.
Yeah, I have explained to you for the foreigner, started from announcement of government to operation, it will be around 6 to 7 years. Yes.
Okay. For the foreign.
Yeah.
Okay. And the second question, well, I don't know what is the question. Maybe you know. In China, how many years validity of operation period?
Sorry.
Excuse me?
Could you please repeat?
In China, how many years validity of operation period? I don't know for sure the meaning of validity of operation period.
Yeah, I could not fully aware about this meaning.
Yeah. Okay. Well, anyway, the important things, the period of the from the announcement until the commissioning is around 5 and 6 years, is it? Or
Yeah.
6 or 7 years, yeah.
Mm.
Yeah. And there is one question also from Yos. This is Yos. Subin, would you explain more, in your opinion, what model of nuclear power plant should be chosen by Indonesian government, or taking into account Indonesia's current geographical conditions? SMR? SMR, it means what kind of technology, whether PWR, molten salt reactor, or STGR. This question is, what is the suitable technology for Indonesia?
Yes, to consider of future country requirement, and also the safety, also the benefits to consider requirements and the benefits of Indonesia, and also to look at the geological the condition of Indonesia. We suggest that ACP100 will be much benefit for Indonesia, because for HTGR it is also good, but it is mainly used for the function, which for HTGR there are advantage of HTGR to connect with the petrochemical industry, and they supply the steam or to the chemical industry chain. But in Indonesia, the mining is required for the generation of electricity, and also seawater desalination and hydrogen produce. This is the most will be stable and advanced in the ACP100.
So your suggestion to use ACP100 as a first SMR Indonesia. Okay. Well,
Yeah.
I think,
it depends on the Indonesia government, because you
sure.
see for the for HDGR 1000, HDGR, it is also cheap and it is also fourth generation, and safety is also advantage. But for Indonesia, if you are prefer to HDGR, we are okay for that because we own the technology. So we, but to consider about the future, long term. So we are suggest it is ACP is most advanced and benefit for the Indonesia, because it is also can enhance benefit for the nuclear industry's development, no matter in the design and development, equipment manufacturing, and also for the floating, because ACP100 is also can using in the floating purpose.
Yeah, I think Indonesia as a big country, islands country also, we need many technologies. The pressurized water reactor, the HDGR, the molten salt reactor. But well, sometimes we have to consider the sustainability. At first, we have to find the proven technology and that already have a supply of chains, the mature supply of chain, for example, that if something happened with that kind of technology for that first NBP, we can find well, internationally or domestically easier than, for example, more advanced like molten salt reactor or HDGR, isn't it, Pak Subin?
Yeah, Dr. Dojat, we are open and we are prefer and we are respect Indonesia government and the citizens. If you are select HDGR or ACP100, we are open for you, and you are most welcome, and we will work with you, and also we can provide technology transfer to the Indonesia.
Okay, there is a question from me. When we communicate with Chinese government and Chinese company, there is one challenge when we want to make a collaboration between China and Indonesia. What it is the challenge? Challenge is the agreement between two countries on the peaceful uses of nuclear technology. Like when Indonesia have agreement with the United States, with Russia and other countries also. So this is our first challenge. For maybe Pak Subin should know to introduce the G2G agreement on the peaceful uses agreement. This Indonesia and China. Without that, it is very difficult. I think we introduced your CNNC's technology to Indonesia. How about your opinion on that?
Yeah, I actually for the currently, as you said, that for future cooperation, the both country has to sign peaceful use agreement for nuclear technology. This is the first step. So as currently both country government leaders, they all have a common sense, and they have a common sense to further improve bilateral cooperation in different areas. And I do believe that for Indonesia government is considering the signing of MOU between China and between China government. And I'm hopeful that it will be coming soon. Yeah.
Hopefully. And there is a question about the SCP-100. I heard that you consider also to build the floating NPP, floating SCP-100 as a ACP100S. What is the status right now? Because some people here, they are interested on the floating power plant.
Yeah, floating power plant. This is one of advantage of ACP100, which can put on the floating, and as Indonesia, you have a different island, and floating, it will be benefit for it will be benefit for the country's energy utilization, right? And it
Yeah.
is also improve the different nuclear floating technology in the sea, and also improve the construction capability in equipment manufacturing, and also which can largely improve the skills in no matter in the nuclear and the shipping as well.
Okay. How is the status right now? Is there under the design, or maybe you want to build sometime in the future?
Regarding the floating, it is already the design is it is matured design, and I'm not sure what is the planning of our government or CNNC, but it is on the timeline, the floating reactors.
Oh, I heard in the news, whether this is correct or not. You want to deploy the nuclear floating power plant in an island or some island in the South China Sea or something like that. Have you heard that?
This I have no idea about this.
Okay.
So I will reconfirm it and reply to you.
Okay.
But floating technology is matured in China, and also China as a big country. I think a floating nuclear power plant will have a very good future and requirement.
Okay, yeah, that's good, because when I communicate with our people with the utility company, they said it is interesting if we can introduce the floating power plant, because we have many small islands in the eastern part of Indonesia. This is very good news if you could also introduce or promote the floating power plant, the ACP100 S. Yeah. Yeah, and this is my another questions about. I think you have competitor in your country like CGN or other or another company, but I haven't heard about similar technology on SMR like CGN. Do they also build the SMR in China?
No, actually, currently in no matter in sorry, for the ACP for SMR currently in China, only CNNC has a technology, and
Okay.
only CNNC has a capability to develop SMR reactors.
Okay.
So other like CGN and SPSC, they are only for commercial nuclear operators.
Okay.
Yeah.
So they don't have a supply, like a nuclear fuel cycle in their company for the fuel supply or other.
No, all the nuclear fuel supply is from CNNC.
Okay. Yeah. So it means when you build the NPP, all of the uranium is coming from your own country, or you also import from outside?
Yeah, actually, we CNNC as the only state nuclear company which we are own all whole nuclear industry chain from exploration to the back end. So we have our complete nuclear industry chain on the CNNC. So for the uranium, so we have a two channel. One is from our domestic, and second is imported from the foreign country. By the way, as we also have investment in the uranium plant in foreign country on the CNNC. And we explored by ourselves, and then we then we processed it, then send it back to China.
How about the enrichment? All of the uranium enriched in China, or maybe you ask, or you send it the enrichment, the natural uranium to a facility outside China?
We send the natural uranium to China from foreign country. Then we process it in our industry.
Okay.
Industry.
So it means you only import natural uranium from outside. Some
Yeah.
part of, okay.
Yeah, we import natural uranium from foreign country, from different countries.
Okay. Yeah. So this is my last question for you. Are you optimistic that you can promote this ACP100, because you are the first one will operate the on-land small modular reactor in the world? It means maybe you have benefits because you have already the term of proven comparing with others. Do you think the potential market in Asian countries or other countries is very good?
Yeah, actually, you have very good idea, and as per our expectation, that also under the IAEA promotion, the emerging market of future for nuclear power plant is SMR, and you can see every country now starting design and the develop of SMR. Because SMR has multi-functions. So
Okay.
we are considered that SMR will in the future under our demonstration, after our demonstration plant go to commercial operation, we will utilize in all area factors, not only from the cost and also from the function, construction, and fuel cost, and it will be utilized systematically for the SMR, and also the foreign country requirement in SMR now it is emerged largely in the different country. They are much interested on the SMR.
Okay. In which country, in your prediction, will build outside China will be the ACP100?
Actually, now the most interested, attracted location is in South Asian and Asian, because you can see the region characteristics, like Sri Lanka. They're also interested in the SMR because due to the foundation issues, they only can use SMR. And like in the Asian countries, like Indonesia and Thai and Malaysia, they are also interested in the SMR because of small and modular and foundation of nuclear power plant, and also the function of SMR and safety.
Okay, so it means South Asia like Sri Lanka and Southeast Asia like Indonesia, Malaysia, even maybe Thailand. They are maybe interested in SCP-100.
Yeah.
Thank you very much, Pak Subin, Pak Musa, for your explanation. I think we have already learned many things about the status of SCP-100. Maybe the audience want to know the small modular reactor. I always say to our stakeholders, the option of SMR, if we want to build the SMR, our first NPP is very small. That already proven, or maybe near-term deployment. Maybe one of the option is SCP-100. This is a good that everyone knows what is SCP-100, the economic parameters, for instance, the investment, about the electricity costs, and how many years it takes from the announcement of the government until the operation. This is very important because sometime in the past, including me, I always use the 10 years. But you assure us it takes not more than 7 years. This is a good. Anyway, thank you very much for your well, sharing out your knowledge about SCP-100. Hopefully, well, I will invite you again for another or other topics about nuclear energy. Thank you, Pak Subin. Terima kasih, Pak
Okay,
Subin.
thank you. Thank you. My pleasure. My pleasure.
Thank you. Demikian Bapak Ibu sekalian, kita mendengarkan penjelasan dari Pak Musa terkait status Small Modular Reactor di Cina ACP100. 100 itu menyatakan kira-kira dayanya sekitar 100-125 gitu ya. Kita sudah mendapatkan penjelasan terkait berapa sih capital cost-nya dari sisi ekonomi, berapa tarif listriknya, meskipun itu tergantung banyak hal, dan berapa tahun untuk bisa mulai pemerintah, misalnya pemerintah Indonesia mau menyatakan go nuklir sampai beroperasi. Memang salah satu hal yang ingin dimunculkan dari SMR itu adalah ini modular, moga-moga lebih cepat daripada PLTN yang lebih besar. Itu kira-kira. Terima kasih atas kehadiran Bapak Ibu sekalian di acara webinar hari ini. Kita ketemu lagi minggu depan untuk topik yang berbeda. Moga-moga sama menarik dengan apa yang disampaikan oleh Pak Musa tadi. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore. Terima kasih Bapak Ibu sekalian ya.
Sama-sama Pak, terima kasih.
Terima kasih. Pak Susilo, moga-moga udah sembuh Pak Susilo ya.
Terima kasih Pak Jarot.
Sami-sami. Sukses semuanya.
Suwun.
Pak Jarot.
Terima kasih.